Imagine this. You're an ancient mathematician in the 1600s, tasked with multiplying two enormous numbers, let's say 3,456 and 7,890. Without a calculator or a computer, this would take hours of painstaking work. But what if I told you there is a way to turn multiplication into simple addition? That's exactly what logarithms do. They transform complex operations into simpler ones, unlocking patterns that make math not just easier, but also incredibly powerful. From predicting earthquakes to optimizing search engines, logarithms are hidden heroes behind some of the most important discoveries and technologies that we rely on today. So, are you ready to uncover the secret language of exponents and discover how logarithms can change the way you think about numbers? Let's dive in. Now let's start with the big question. What are logarithms? A logarithm is essentially the inverse operation of exponentiation. Think of it like subtraction being inverse of addition or division being inverse of multiplication. Here's a simple way to think about it. If I ask you, to what power do I need to raise 2 to get 8? The answer is 3, because 2 to the power of 3 is equal to 8. Now, instead of saying that in words, we can write it as log of 8 to base 2 is equal to 3. So in general, if b to the power of x is equal to y, then the logarithm base b of y is equal to x. Let's take a closer look at the parts of a logarithmic expression. Let's consider this. You remember earlier, we gave an example, or rather, it was a question, where we said, to what power do we need to raise 2 to get 8? If we look at our board where we are writing, it's in this form. We are saying 2 to the power of x is equal to 8. X is the value that we do not know, which is the power that we need to find out, to which we will raise 2 to get 8. So in this case, we'd say that 2 to the power of 3 is equal to 8. Because if you raise 2 to the power of 3, you get 8. So the value of x is 3. We can see that this equation is in the form of b to the power of x is equal to y. Now, let's consider this example, because we need to see how we can take exponentiation and convert it to a logarithm and understand the relationship between the two. Let's write down the structure of a logarithm. So it's log base b of y is equal to x. What is b? So b is the base. This is the number you are raising to a power. In our earlier example, here it's 2. The argument y, this is the result of raising the base to a power of x. In our example, y is equal to 8. So what is x? This is the power, I'll call it power, or exponent, that satisfies the equation b to the power of x is equal to y. To summarize, we can say that, as we have seen, that log of y to base b is equal to x is equivalent to b to the power of x is equal to y. Let's do a few more examples together. Let's say we're given this question. Logarithm of 27 to base 3 is equal to x. And we are asked to solve for x. We want to find the value of x. This is the same as asking to which power do we raise 3 to get 27. We know that this is the base, this is the exponent, and this is the result of raising 3 to the power of x. So we go ahead and do this. 27 is equal to 3 to the power of x. But we know that to get 27, we need to raise 3 to a power of 3. So 3 to the power of 3 is equal to 3 to the power of x. The value of x is equal to 3. So by raising 3 to the power of 3, we know that the value of x is equal to 3. We know this through the laws of indices. We are going to cover this topic in the next tutorial, but as of now, let's just know that when the bases are the same, the exponents are equal. So x is equal to 3. This is how we find the value of x. Just like exponents, logarithms have some important properties that make them easier to work with. Here, let's write rules of logarithms. The first rule is the logarithm of 1. We should always know that logarithm of 1 to base b is equal to 0. So no matter what base you are using, the logarithm of 1 is always equal to 0. We have log of the same number as base. This states that the logarithm of b to base b is equal to 1. The logarithm of b to base b is equal to 1. We have the product rule. Let me scroll down just a little bit. So, product rule. The product rule states that the logarithm of m times n to base b is equal to the logarithm of m base b plus the logarithm of n base b. We have the quotient rule. The quotient rule says that the logarithm of m over n to base b is equal to the logarithm to base b m minus the logarithm of n to base b. Let's scroll just a little bit more and move on to the next rule. We have the power rule. The power rule. So the power rule says that the logarithm to base b of m to the power of n is equal to n times the logarithm of m base b. The change of base rule. It states that the logarithm of b base a is equal to the logarithm of b base c over logarithm of a base c. So we can express it in this way. Logarithm of a base c times logarithm of b base a is equal to logarithm of b base c. My desire was to prove how these logarithms relate to exponentiation. But because this video is getting too long, I'm going to stop here. In the next video on logarithms, we're going to do more questions and we are going to prove how these rules relate to exponentiation. Let's recap. Logarithms are the inverse of exponentiation. They help us solve equations involving exponents and simplifying complex calculations. There are important rules, product rule, quotient rule, power rule, and so on that make working with logarithms much easier. Remember, practice is the key to mastering logarithms and math in general. Keep working on problems and you'll get the hang of it in no time. If you enjoyed this content, please like this video so that it can reach out to more people, and subscribe so that you won't miss content from this channel. You can also share this video with your friends to help this channel grow.